The title of my lecture today, Universal Quaternionic Field Equation. The plan of my lecture consists of 3 points. At the beginning, we will consider a relativistic relation between energy and momentum. Then we will discuss the universal quaternionic second-order wave equation. And at last, we will consider quaternionic first-order wave equation. So, relation between energy and momentum was discovered by Albert Einstein. Here you can see the expression for this relation. Here is energy, momentum, speed of light, and m is the mass of particle. The same expression can be written for the waves of different fields. Indeed, if we take the quantum mechanical expression for energy and momentum, here omega is the frequency of a wave, k is the wave vector, and h is the Planck's constant, we obtain the following dispersion relation for the wave. Here, m is not mass of particle, of course. Here, m is the mass of quantum of field. In particular, if mass of quantum is equal to 0, we obtain the well-known expression for electromagnetic waves. The expression for energy and momentum can be factorized using algebra of Macfarlane quaternions and space-time quaternions. Indeed, if we use the space-time basis, we can represent our expression in the following form as the product of two terms. The same expression is valid for the operators of these values, for operator energy and momentum. If we take the expressions for operator of energy as a time derivative and for operator of momentum as the gradient, and act by our complicated operator on Sidionic wave function, we obtain the following wave equation. This is the universal wave equation for different fields. Indeed, if we multiply our operators on the left side of our equation, we obtain the well-known so-called Klein-Gardon wave equation. If we take the mass of quantum is equal to 0, then we obtain the well-known wave equations for electromagnetic field, for example. So, among the solutions of this wave equation, there are a special class of solutions which satisfy the first-order wave equation. Indeed, if our wave function satisfies first-order wave equations, then it satisfies the second-order wave equations automatically. If we would like to take into account sources of our fields, we should place on the right side of our equations sources of our fields, G and I. These two equations can be applied for the description of different situations, for description electromagnetic field, weak gravitational field, can be applied for description of hydrodynamics of vortex flows, hydrodynamics of plasma, electrodynamics of superconductors, and for description of strong and weak interaction. I'll try to tell you about all these topics in my next lectures. As a conclusion, I would like to emphasize that the space-time algebra of Sidions allows us to factorize the relativistic relation between energy and momentum and write universal wave equations for various fields. And at last, I would like to recommend you our book, Space-Time Sidions and Via Application in Relativistic Quantum Mechanics and Field Theory. Here you can see the link to this book. It is available through the internet. Also, this link will be given in the comments. If you would like discuss something, or maybe you have some questions, you can write me using this email address. Thank you very much for your attention.